In this presentation, we'll explore the process of migrating from other version control systems to Git. Specifically, we will focus on converting repositories from Subversion, Mercurial, and other version control systems to Git. There are several compelling reasons to migrate to Git. First, a distributed workflow allows you to work offline with full repository history and commit locally before pushing changes. Second, branching and merging. Git's lightweight branches make feature development and experimentation easier. Third, performance. Git offers faster operations for most common version control tasks. Fourth, ecosystem and tooling. Git integrates extensively with modern continuous integration and continuous delivery. Finally, content addressable storage ensures data integrity through secure hash algorithm 1 hashing. Also, there is a large developer community and extensive documentation available. Effective migration requires careful planning. First, create an inventory of all repositories, branches, and tags. Second, choose appropriate migration tools based on the source version control system. Third, perform trial migrations with sample repositories. Fourth, prepare your team for Git workflow differences. Finally, migrate repositories with proper validation. Some key considerations include timeline or freeze periods during critical migrations, how much history to migrate, creating user mapping between the old version control system and Git, updating continuous integration and continuous delivery pipelines, and defining success criteria for migration verification. For Subversion to Git migration, Git provides a built-in tool called git-svn that allows you to use Git as a client for a Subversion repository. The command is git-svn clone, then the universal resource locator of the svn repository, then /project, then standard layout, no metadata, authors file equals authors.txt, and local Git repository. To push to a new Git remote, use the command git remote add, then origin, then the universal resource locator of the Git repository. Then git push -u origin, then --all. Finally, git push origin, then ---- tags. Subversion and Git have different approaches to repository organization. In Subversion structure, we have project, trunk, branches with feature 1 and feature 2 folders, and tags with version 1.0 and version 2.0 folders. In Git structure, we have project.git, and then main branch, feature 1 branch, feature 2 branch, version 1.0 tag, and version 2.0 tag. When migrating from Subversion to Git, author information needs to be converted from Subversion usernames to Git's name or email format to maintain proper commit attribution. First, extract all unique author names from your Subversion repository. Second, create an author's mapping file with Subversion username to Git name email pairs. Third, use the mapping file during git-svn clone with the --authors file parameter. Finally, verify author information in Git history after migration. Here is the command to extract all unique authors from Subversion: subversion log, -q, pipegrep, !r, pipeawk, print $3, pipesort, -u greater than authors.txt. In the example authors.txt file format, we have username Smith equals John Smith within angular brackets, john.smith at example.com, username Jones equals Mary Jones within angular brackets, mary.jones at example.com, usernamed Kim equals David Kim within angular brackets, david.kim at example.com, username Ali equals Alice Lee within angular brackets, alice.lee at example.com. Use the git-svn clone, the universal resource locator of the Subversion repository, --authors file equals authors.txt, ---- standard layout, local Git repository command to include the authors file in your git-svn command. Migrating large repositories comes with its own set of challenges. First, long migration times, as large repositories with extensive history can take days to migrate. Second, storage requirements, as Git stores complete history locally, requiring more disk space. Third, network bandwidth, as transferring large repositories can strain network resources. And fourth, large binary files in history can bloat repository size. Fortunately, there are solutions to these challenges. First, use Git's shallow clone to limit history depth with the command git-svn clone, --depth equals 100, then the universal resource locator for Subversion repository. Second, split large monolithic repositories with the command git subtree split, -p path to folder -b split branch. Finally, use git large file storage for large binary files with the commands git large file storage install and git large file storage track, zip, PDF, PSD. For Mercurial to Git Migration, the fast export tool converts Mercurial repositories to Git format while preserving history, branches, and tags. The commands for this are git clone the universal resource locator for fastexport.git, then make directory git repository and change directory into it git init and then /fastexport/hg fastexport.sh-r the path to hg repository, then git checkout head. Mercurial's change set is git's commit. Mercurial's named branch is git's branch. Mercurial's bookmark is git's branch. Mercurial's tag is git's tag. Mercurial's hg update is git's git checkout. Mercurial's hg pull is git's git fetch. To migrate from Perforce to Git, Git provides a built-in tool called Git P4 that allows you to import Perforce repositories into Git while preserving history. The command to clone a Perforce depot is git p4 clone, /depot/path/to/project et al. The command to import a specific change list range is git p4 sync, /depot/path at 1000, 1500. And the command to submit changes back to Perforce is git p4 submit. For large repositories, consider using the --detect branches flag to properly convert Perforce branches. The command for this is git p4 clone, /depot/path/detect branches. Key considerations for this migration include branching model. Perforce uses file paths for branches while Git uses references. Also, workspace mapping. Convert Perforce client specs to Git repository structure. Additionally, file locking. Git large file storage can provide similar functionality to Perforce file locking. Also, large binary files. Use Git large file storage for large binary assets common in Perforce repositories. Finally, create a mapping between Perforce users and Git authors. After migrating to Git, there are several essential tasks to perform. First, clean up the repository. Remove unnecessary files and optimize repository size. Second, update documentation. Update README and contribution guidelines for Git workflow. Third, configure continuous integration and continuous delivery. Update build pipelines to work with Git repository. Fourth, team training. Ensure team members are comfortable with Git workflows. Finally, access control. Set up proper permissions and access controls. Verification commands include git revlist, --count, --all to check the commit count matches the source repository. Also, git branch -a to verify all branches were migrated. Finally, check repository size with do-sh git, and clean up and optimize with git gc --aggressive. Here are some best practices to keep in mind. Always perform trial migrations with sample repositories. Schedule migrations during low activity periods. Keep detailed records of migration process and decisions. Consider migrating repositories in batches rather than all at once. Keep team members informed throughout the migration process. There are many helpful resources available, including Git source code management documentation, Git SVN manual, Git P4 documentation, the subject, fast export, and Git large file storage tools, and the Pro Git book. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.